Our work is an experimental study upon the damage, failure, and energy absorption characteristic of foam core sandwich panels subjected to low-velocity impact. The components of the sandwich panels are presented in Table 1, and their configuration is illustrated in Figure 1. Face sheets are of two major types, aluminum and fiberglass reinforced composites. Also, as presented in Table 2, composite face sheets are of three types, depending on the amount of short glass fibers added in the matrix. Two commercial foams of different densities are used as core, namely polyurethane and polystyrene foam. Impact tests were conducted using an Instron impact testing machine presented in Figure 2. This is a gravitationally accelerated drop tower that can reach impact velocities up to 4.6 meters per second. Table 3 presents the impact parameters that we used. Table 4 presents the average mass of all tested sandwich panels as well as the main parameters resulted after impact. Based on this, three energy absorption quantifying parameters were calculated. Figure 3 presents the variation of the normalized absorbed energy as a function of impact velocity. For sandwich panels with composite face sheets, irrespective of core type, this parameter decreases with increasing impact velocity. Two similar parameters are presented in Figure 4, the specific energy absorption and the crush force efficiency. For a structure to have good energy absorption capabilities, both these parameters should have high values. It can be seen that even though aluminum sandwich panels fail in a progressive mode, they do not manage to absorb enough impact energy per unit mass. Table 5 and Figure 5 present a summary of the damage events induced by impact loading in sandwich panels. It can be seen that composite sandwich panels are most of the time severely damaged and even completely perforated for the highest impact velocity. Aluminum sandwich panels instead are less damaged and perforation occurs only on the upper face sheet of the panels, with polyurethane foam core at higher impact velocities. The energy absorbing capability of the sandwich panels is affected by the initial impact velocity on one hand and face sheets and core type on the other hand. Thus, the choice of using a specific type of face sheet or foam core must be carefully analyzed and depends on the purpose of the engineering application. At lower impact speeds, the composite panel is surpassing the aluminum one in terms of specific energy absorption. At higher impact speeds, this parameter is about the same. For composite panels, the damage area of the top face sheet is reduced if the face sheet is stiffer, type C versus type A, and by using the more rigid core, polyurethane versus polystyrene.